for a short pulse? What happens when I have a short pulse?
It's going to be more spread out.
Spread out. I was exaggerating there. So let me write it up here. So what do we say, a long pulse time for a long pulse we get close zero rest, I guess it is really close. And then for a short pulse, I use the very technical term far away. What does this mean from, so this is time domain here, and frequency domain there. If I looked at this signal, so where is most of the energy of my signal? Energy being the area under the curve. Where's most of the area under my curve of the sinc function? Remember, it's decaying by 1 over x. Where's the area biggest?
Where's this at the first part?
In this first part, right? So most of my energy is contained there, right? The rest is decaying. So what does this say about how big of a bandwidth, how much frequency I need in order to transmit a pulse? If I have a long pulse, here's my energy. If I have a short pulse, there's my energy. What about the bandwidth that I need for these two systems? Bandwidth meaning how much frequency I need. Should I just get my car and go to Michigan now? What's going on? But
you're gonna need a low frequency, I guess, for the long pulse and a high frequency for the short pulse.
yeah, I need a lot of frequency in order to get this pulse through the channel, right? If I have a short time domain pulse, the energy is spread out over a wider frequency range. So I need more bandwidth. If I have a long pulse, where's my long pulse? I guess I didn't draw the pulse. But if I have a long pulse, then my energy is more closely centered around the origin, which means a smaller frequency, right? I don't need as much bandwidth in my channel to transmit that pulse. So how does this relate to like modern day life? What's your internet access at home? Anyone ever remember the days of dial-up? Right? How much bandwidth, or what was your data rate then? 56 kilobits per second? Right, so that means the pulses were a in order to get 56,000 pulses in a second, they had to each be a slice of that, right? 1/56 of that, right? So they could all share that. What's the throughput now with like DSL or cable?
It's like 10 megabits.
Yeah, 10 megabits, something around that, right? So you went from 56K to 10 meg. So what happened to the size of the pulses in time, the width of those pulses? They get bigger or shorter? Yeah, sure, right? Here I only had to put 56,000 per second, right? Now I've got to put 10 million pulses in that same second interval. So each pulse got a lot shorter. What happened to the bandwidth required to do that? It got bigger, right? And that's why you couldn't do dial-up anymore. Because the phone wires that were buried in our homes were just twisted, in some cases not even twisted. So they couldn't support, they didn't have the bandwidth to put these short pulses. We had to go to coax cable and the cable company that can support a much wider bandwidth in order to get these tiny little pulses in. And then the phone company said, well, wait a minute, we're not going to lose out on this. We'll put in DSL, which meant that they had to redo every wire on the telephone pole come into your house so that they could do that, so that it get a bigger bandwidth, get these short pulses. And that's why the sync function is so useful with, especially communication theory. If you go into communication, you'll see a lot of use of the sync function because it relates what the width of my pulse is to what I physically need to support in my channel in terms of the data rate and stuff like that. All right. So by far the rec function and the sync function are the most widely used Fourier pair. But there are other ones. Triangle. Cleverly referred to as a triangle. Triangle and a T. Triangle, I can't even do it. Triangle and a T is equal to 0. Magnitude of T greater than equal to 1/2. 1 minus 2 absolute value of T. Absolute value of T less than 1/2. That's just the mathematical equation for it. We can scale. Oops, I guess I didn't put the units in here. 1/2 minus 1/2 and a height of 1. And these are defined functions, right? Mathematically defined. Scale. Minus tau over 2, tau over 2, 1. And then this would be triangle of T divided by tau. Again, tau would be the the base